Hey guys, welcome to the Level 3 Calculus integration paper from 2023. Now if you're joining us for the first time, the way this video works is that I go through each question and let you know what you need to do for achieve merit and excellence. The best way to watch this video is to pause the video at the start of each question, try the question out by yourselves, and then unpause the video to see how I go about answering the questions. So without further ado, let's get started. Alright folks, so let's get started with question 1a. So question 1a, what we've got is just a basic integration question here. So 3x, that's going to integrate to 3x squared over 2. 2 will integrate to just 2x. Now when we have 1 over 3x plus 2, we're going to have ln of 3x plus 2. And of course you got to divide by the differentiation of whatever's in that bracket there, which is going to be 3. And of course we've got plus c to go along with the end. Now in terms of grades for this question, it does say that correct integral required, plus c is actually not required to get an achieved. It's quite nice of them to not worry about the plus c, but that's pretty much question 1a. Moving on to question 1b, we've actually got a kinematics question as an achieved. Alright, so looking at this, we've got initially the object was 3 kilometers from a point P. So that's basically saying that when t is equal to 0, the displacement s is equal to 3. And the question's asking from point P after pi over 4. So basically we're looking for s of pi over 4, or I guess you can always call it d as well. Because it is distance. Alright, so we've got v of t is equal to sec squared t. Now if you look on the side there, sec squared x, integration of sec squared x is tan x. So we're going to write s of t is equal to tan of t. And of course don't forget the plus c. So once we have that, now we know that s of 0 is equal to 3. So we're going to put down 3 is equal to tan of 0 plus c. Now tan of 0 is 0, so we're going to get 0 is equal 3 is equal to 0 plus c. So c is equal to 3. So our distance formula is tan t plus 3. And we're trying to find it for pi over 4. So then we've got tan of pi over 4 plus 3. And so we're going to use the calculator for this. Now, where is my calculator? There we go. Just make sure that your calculator is actually in radians, because we do have pi over 4. Go back to menu, and we're going to do tan, oh, sorry, where did I go? Exit tan of pi over 4. I always don't like that calculator doing that here. And then we've got plus 3. And so you should get an answer of 4 kilometers. Now, correct solution with the evidence of correct integration, that's going to give you an achieved for this question. Moving on to question C. So with this particular question, find the shaded region, and I know that my image right there is actually not showing the shaded region, but it's actually this part right here that's highlighted in yellow. And so the way we're going to do it is finding area between two curves. We just do top minus bottom and the two intervals. So I guess the first thing is trying to figure out what this value here is. This one here is pretty self-explanatory. It's 0. So what we're going to do is we're going to put down square root of x equals x squared over 8. Now, I for one, I mean, you can just kind of how do I say this? You can actually just solve it, or you can actually just put it in the calculator. You can put like 2 graphs in the calculator and work it out. So I'm going to do it this way here. So I'm going to go 8 times root x is equal to x squared. And then what I can do is square both sides, which means I'm going to get 8, no, not 8. I'm going to get 64x is equal to x to the power of 4. And then 0 is equal to x to the power of 4 minus 64x. And then 0 is equal to x cubed. So sorry, take x out as a common factor. X cubed minus 64. So that means x is equal to 0, or x cubed minus 64 equals to 0. and we're going to get x cubed equals to 64, and then x is equal to positive 4. So that's the long way of doing it. Now you don't need to actually do this in the exam. You can actually just use the calculator straight away. So the best way to do this is I would actually put this in graphs. So I would actually put down square root of x. So I'm going to go square root of x, and then I've got x squared over 8. So put those two graphs. I'm going to click on draw, and then I'm going to g-solve intersects. So there's my first point, which is 0, 0, and then there's my second point, which is 4 and 2. By the way, I just realized I missed one important step there, which is just rearranging this as y equals to x squared over 8, then actually putting both of those equations equal to each other. All right, now as I said to you, you can actually get these points from the graphics calculator, and so when we do that, we're going to get it between 4 and 0, and it's going to be the top graph minus the bottom graph. Now the top one is square root of x, and the bottom one is going to be the 8y equals x squared. So we've got square root of x minus x squared over 8 dx. Once we get that, we just need to integrate this. So we're going to get, actually before integrating it, I just want to write this square root of x as x to the power of half minus x squared over 8 dx. So now when I integrate this, I'm going to get x to the power of 3 over 2 over 3 over 2 minus x to the power of 3 over 8 times 3. And all of this is between the limits of 4 and 0. Now, when I have actually done these questions, on paper, what I tend to do is I kind of do this and then I just substitute the values. So I go 4 to the power of 3 over 2 over 3 over 2 minus 4 to the power of 3 over 8 times 3 minus, I've got 0 to the power of 3 over 2 over 3 over 2 minus 0 to the power of 3 over 8 times 3. So you can put this in the calculator and you can actually kind of work out the answers because we've done pretty much most of the work. But I always suggest this to folks is that, because you have the graphics calculator and you've actually shown all the working, just go into option, calc, and then integral, and then just put in your function in there. So I'm going to do square root of x minus x squared over 8. Then what I'm going to do is make sure I put my two limits, which is 0 and 4. And when I do this, I actually get 2 2/3. And if it's 2 2/3, what can I do? I can write this as a fraction. Can I write this as a fraction? I should be able to. I have to actually figure it out. I don't know how to do this in this calculator. But 2 2/3 is what the final answer is. And you're pretty much done with this question. So now, if you were to do this in the graphics calculator and you just put down your final answer as 2 2/3, you will probably not get any solution because, you won't get any marks because the answer schedule, if you have a look at the answer schedule, it actually says that correct integral is going to get you an achieved. So getting to this part here is going to get you an achieved, and then correct solution with evidence of correct integration gets you a merit. So don't just write the answer down, make sure you actually put down your working as well. So that's going to be a merit there, and then your achieved is this part right here. All right, so with the next question, what we've got is consider this differential equation. They're given that y equals 1, x equals 2, find the values of y when x equals to 1. All right, so what we're going to do is we are going to separate the y's and the x's. So this will become dy divided by y equals 2x minus 3x squared dx. Once we do that, we're going to integrate both sides. So here we've got 1 over y. When we integrate it, we're going to get ln of y equals 2x squared over 2 minus 3x cubed over 3 plus c. I'm going to cancel the 2's and the 3's out, and what I'm left with is just ln of y equals x squared minus x cubed plus c. Now, getting up to this part of this question is actually going to get you an achieved, but we're going to carry on. So our first clue is that when x equals to 2, y is equal to 1. So we've got ln of 1 equals 2 squared minus 2 cubed plus c. ln of 1 is equal to 0. So we've got 4 minus 8 plus c. And what we're going to get is 0 is equal to negative 4 plus c. So c is equal to positive 4. Now if c is positive 4, then our ln of y is equal to x squared minus x cubed plus 4. And what we want to know is when x equals to 1, what is y? So we're going to go ln of y equals 1 squared minus 1 cubed plus 4. We're going to get ln of y equals 1 minus 1 is 0. We're going to get ln of y equals to 4. And therefore y is equal to e to the power of 4. Now we don't need to actually solve e to the power of 4. We can actually leave it like that. And when we do, that is pretty much a merit question there. Awesome. All right, let's go to the next question. Whew, that's a beast. All right, folks. So for this question here, the shaded region that we're looking at is this part here. So basically this entire thing here. Sorry, it's just my lighting here is not doing it justice. All right, so what we can do, the answer schedule has done it in, the way they've done it is they've done it in 3 kind of parts here. So first, they've actually created a little triangle shape here as the zone 1. Then they've created a second one, which is maybe not that color. Let's go with a different color here. So this part here as zone 2. So they've zone 2 is the red part, and then zone 3 is the yellow part there. Lots of ways of doing this particular question. So you could do the zones, so you could actually go zone 1, zone 2, zone 3, and you can actually work out each one of those zones separately and then try and figure it out. That's one way of doing it. The other way you could also do is you could actually do top minus bottom, but you would have to split it up into 2 parts. So you would go top minus bottom for the side that's actually, well, the parts that are to the left of the red line, and then to the part of the 2 and 3 on the right side. So it's kind of like this. So where you go, I'm running out of highlighters here. I'll go orange here. So this becomes like top minus bottom. So that's like one side of the zone. And the second zone is like the top minus bottom there. So either way you do it, as long as you get to the final answer, then you're pretty much good to go. Now, I am not going to do the method that's shown in the answer schedule, which is they've actually done it with zone 1, zone 2, and zone 3. I'm going to attempt the top minus bottom with this case. All right, so now to do that, the first thing I need to figure out is this particular point right here. I need to know what this point is. Now, you've got y equals to 3x and y squared equals 10 minus x. So what I'm going to do is like I said, these kind of, when I'm going to find points, I'm not going to sit there doing algebraically because that's just going to waste a lot of time, and quite easily you can make mistakes with it as well. So all I'm going to do is, we've got 10 minus x. Okay, so I'm going to put that as y square root actually. Because it's y squared, I'm going to put that as square root of 10 minus x. Hopefully I can draw this. Yes, it does draw it. Okay, so as you can see, somehow my calculator's disappeared. Oh no, I can see why. There we go. So what I'm going to click on is, I'm going to click on GSolve, and I'm going to click on intersect, and there is my point. My point right now is 1 and 3. I don't really care about the y value. I only care about the x value. Okay, so what that means is I've actually got 2 zones here. I've got zone A and zone B. So with zone A, I am going to do it between 1 and 0, and I've got 3x, which is the straight line, minus negative sine pi x over 10, plus then the next one is I need to figure out this point right here. Now this one is fairly easy, because if x is equal to 10, then y squared is equal to 10 minus 10, and that's 0. So this point right now is actually 10, 0. So my second zone is going to be between 10 and 1. And for this one, I'm going to have 10 minus x minus negative sine pi x over 10. Now, as I said to you before, like I'm attempting this in a different method compared to the answer schedule. Let's see what happens. I'm looking for a final answer, but anyway, let's just see how this goes. So folks, just to kind of recap, this is this little box here, and then this box is this one here. So it's the two little boxes that I'm looking at. I'm going to find what the area between those two curves are, and hopefully this actually works out. Now I realize what my mistake was here with this particular thing. I should have actually put this as square root of 10 minus x, not just 10 minus x. All right, so let's kind of get rid of that square root and put that as 10 minus x to the power of half. And let's try this again. Sorry, I did do this before, and I did it with 10 minus x, and I made a mistake, and I realized it took me a while to figure that out, where that mistake was. But anyway, here we go. Let's try this again. So we've got 3x squared over 2. Negative sign is plus sign, so that'll become integral of plus sign is negative cos. So we're going to get negative cos pi x over 10. Now you got to divide that by the differentiation of this bracket here, which is pi over 10. And all of this is between 1 and 0. Then we've got plus 10 minus x. Got to do a little bit of reverse chain rule there. So what's that going to be is we're going to get 10 minus x to the power of 3 over 2 divided by 3 over 2. And we've also got to multiply by the differentiation of whatever this bracket is, which is negative 1, reverse chain rule there. And we've also got the same cos thing that's going to happen as well. So it's going to be ending up with negative cos pi x over 10 divided by pi over 10, which is the differentiation of whatever this bracket is. And that's between 10 and 1. Now, of course, trying to substitute, I always like to do this again. Like, I mean, I would show the marker that I know what I'm doing by substituting the values, but trying to do this in the calculator is just exceptionally painful. So I am going to use a shortcut, but what I am going to do is before doing that, I'm going to show the marker that I know what I'm doing. So it's 3/1 squared over 2 minus cos pi times 1 over 10 over pi over 10 minus, then I've got 3 times 0 squared over 2 minus cos of pi times 0 over 10 over pi over 10 plus, now doing the second bracket, which is going to be 10 minus 10 to the power of 3 over 2 over negative 3 over 2 minus cos of pi times 10 over 10 divided by pi over 10 minus I'm going to get 10 minus 1 to the power of 3 over 2 over negative 3 over 2 minus cos pi times 1 over 10 divided by pi over 10. So as you can see, trying to put this in the calculator is going to be like insanely crazy. And I am going to show you what I did in my previous question there. So you can see what I did just before I actually did this question, and I did it with the 10 minus x and I made a mistake, but I did put this all in the calculator, and I just got to figure out how to actually make the 10 minus x as to the power of half. Okay, there we go. I'm going to put 10 minus x as to the power of half. There we go. Now I'm hoping this is going to work. All right, so the answer that this gives me is 25.866. So I'm going to put this here as 25.866. So as you can see, I'm not going to sit there putting this entire equation in the calculator because I know I'm going to make a mistake somewhere. But what I have done is I've actually shown the marker that I do know what I'm doing by actually substituting those values. But at the end of the day, I'll just use the calculator. Oh, sorry, I just realized that the calculator was off. No, there we go. Oh, God, I'm sorry. I kind of messed that up a bit. I don't think there's an undo button in this calculator, is there? No, there is. I don't know where it is. So yeah, so I basically used the option and integral function, this one here, and I literally just put our two equations together. And if you look at the actual answer schedule there, you know, they've done it differently. They've done area of triangle, then they did area of B, that's the zones that we were talking about. And then they added it all together to get 25.866. The way I did it, is I did top minus bottom. They did the whole green, yellow, red, 3 separate things. 2 ways of doing this, still ending up with the same answer. All right, so let's have a look at grades wise what you're going to get. Correct integration of one of the expressions is going to get you achieved. So achieved in this line, so one of them. Correct evaluation of area B and C. Man, that's, I guess because I did this slightly differently, that's a bit mean. How would that happen? I guess if you get one of this part correct, you probably would be getting a merit. And if you get the final one, you're going to get the excellence grade. Now it does say E7 is solution with one minor error. Now let's say I put something wrong in the calculator, but I've actually shown all the working. That might still get me, like this right here should be able to get an E7 because I've actually shown all of my working there. And if I just enter it wrong in the calculator, I might have got a little mistake there. Cool, that's question 1. Let's go to question 2, folks. All right, question 2, what we've got is just a very nice integral question. So we're going to have 4e 2x minus 1, and it's going to get divided by the differentiation of the power, which happens to be 2. And don't forget the plus c. A lot of folks, I don't know why, you know, when it comes to exponential, they treat it exactly like x, and they start adding 1 to the power and things. Remember, whenever you're working with exponential equations, it stays the same whether you integrate or differentiate. There's a couple of rule changes, but nothing major there. Right, so that's going to end up with an achieved, and we go to the next question. Right, so question B, what we've got is a differential equation, but really, I mean, this is just, I mean, you can kind of just treat this like a normal y equation, because if dy dx is that, then y is equal to the integral of 4x plus 1 to the power of negative half dx. So y then is going to equal 4x plus 1. Negative half plus 1 is going to become positive half. And so negative half plus 1, that's going to be positive half. And one more thing that we need to remember is we also need to multiply by the differentiation of this bracket, which happens to be 4. And don't forget the plus c. So we've got y is equal to 4x plus 1 to the power of a half divided by 2 plus c. Now it does say when x equals to 6, y equals to 7.5. So we need to figure out what the c value is. So x is equal to 6, y is equal to 7.5. I'm going to carry it on here. 7.5 equals 4 times 6 plus 1 to the power of half over 2 plus c. Now that's 4 times 6 is 24, plus 1 is 25. 25 to the power of half, that's going to be 5. So we've got 5 over 2 plus c. And then we've got 7.5 equals 2.5 plus c. So c is equal to 5. So our equation is going to be y equals 4x plus 1 to the power of half divided by 2 plus 5. Now this question is just an achieved question, folks, because all it is asking you to do is just integrate and find the c value. All right, so moving on to the next question. This question here, this question. I love this question, but you know, I always struggle to do the yeah, I'm gonna patent this, and I'm gonna give a shout out to Lauren Harris right now. This person here was working with me this year in 2024 in integration, and then she came up with this shortcut, and I don't know, I can't do it. I can't do the Lauren Harris method, but I'm going to give a shout out to her. But anyway, the way we've got to do this is we've got to separate this, right? I did it during the streams, but I forgot after that. I'm sorry. I'm so sorry. But the way I do it is like I do long division, so 2x minus 3, and then I do long division of 6x minus 3. Basically I go 3 because that's 3 times 2x minus 3 is 6x minus 9, and this ends up becoming minus 3. 6x minus 6x is 0. Negative 3 minus 9 is 6. So basically I just rewrite this as k2. We're going to get 3 plus 9 over 2x minus 3. And of course this is equal to 3k. Now interestingly enough, like if you do know other ways, I mean, I know I'm saying it's the Lauren Harris method, but if you do know how to do that method and you get to this part, by all means, go for it. Good luck if you know how to do it. I just forgot it. That's my bad. Anyway, we're here. We're going to integrate this. So 3 integrates to 3x, and then 9 over 2x minus 3 will become 9 ln of 2x minus 3, but we've got to divide by the differentiation of this, which happens to be 2. And with that, I think I missed something here. I've messed up something here. Yes, I realized what I messed up with. That should be 6. That's better. And then we don't need to worry about the plus c. So this is just going to be between k and 2, which equals to 3k. So simplifying this, we've got 3x plus 3 ln of 2x minus 3. And that's between k and 2 equals to 3k. So all we have to do right now is we just need to substitute all of these things and put it equal to 0, and then we should be pretty much, well, equal to 0, whatever it comes out to be, we should be good to go. So let's just have a look at this. What am I doing? I'm going to substitute k first. So I'm going to get 3k plus 3 ln of 2 times k minus 3 minus, I'm going to get 3 times 2 plus 3 ln of 2 times 2 minus 3. Close the bracket, and all of this is equal to 3k. So from here, I've got 3k plus 3 ln of 2k minus 3 minus, and I'm going to do this bracket here first, which is 6 plus 3 ln of 2 times 2, 4. 4 minus 3 is 1. Close bracket, that's equal to 3k. Then I've got 3k plus 3 ln of 2k minus 3 minus 6. Now ln of 1 is 0, so that's just going to become minus 6. And that's all equal to 3k. The two 3k's cancel out each other, and I've got 3 ln of 2k minus 3 minus 6 is equal to, I'm just going to put that there anyway, just in case people kind of go, where did that 3k go? So this is this 3k here. So then I've got 3 ln of 2k minus 3 minus 6 is equal to 0. Carry on here. I've got 3 ln of 2k minus 3 equals to positive 6. ln of 2k minus 3 is equal to 6 divided by 3. ln of 2k minus 3 is equal to 2. Then I can just say 2k minus 3 equals e to the power of 2. 2k is equal to e to the power of 2 plus 3. And then k equals e to the power of 2 plus 3 over 2. And I can actually leave my answer like this. You don't need to solve it or anything. Grades wise, correct integral is going to get you a achieved. So achieved is there, and then the final answer is worth a merit. I know it seems like a lot of work for a merit, but it's just substituting things there. All right, let's go to question D. Cos 2x plus sine 2x. Right. This is one of these really annoying questions. I'm not gonna lie, right? Like. You on first look, you look at this and you go, wait, am I going to use this? Where is this? Let me just grab it. Hold on. I was having a look at the formula sheet actually. So having a look at the formula sheet here, you automatically go into products and you're like, well, sine cos, and then you've got sine plus sine. Going back to our question, we've got cos 2x and minus sine 2x at the bottom. Now, unfortunately, that's not going to work. This is not going to work. And you might be thinking this compound angles, no, this is not going to work as well, because we've actually got cos 2x and sine 2x at the bottom. Then you're thinking, do we go sums? But sums is sine and sine, sine and sine, cos and cos, cos and cos. Where do we have? And then this one is sine a plus b and a minus b. These are not even the same values. So suddenly we get to this point where, like, we can't use any of these things. What do we do here? And I always say this, right? I mean, you know, if you're stuck with something, go substitution. Substitution always tends to kind of work out magically. So what I'm going to do is I'm going to use the denominator. I want to get rid of the denominator. So I'm going to put down u is equal to cos 2x minus sine 2x. So if I do u as cos 2x and sine 2x, then du over dx would then become, what is it? Cos, differentiation of cos is negative sine. So that's going to become negative sine 2x multiplied by 2. I should probably put the 2 in the front actually. No, I'd put this in the bracket actually. So I'd have to multiply by the differentiation of the 2x, which is 2. Then I've got minus sine 2x. If I differentiate minus sine, I am going to get negative cos 2x. And of course, I've got to multiply this by 2 as well, because that's the differentiation of this. Now, hopefully, you can see something here, because you can actually rewrite this as du over dx equals minus 2 times sine 2x plus cos 2x. And suddenly, you can start seeing things happening here, because you can actually say du over negative 2 equals, I'm just going to write cos first, all right? And you'll see why. I'm going to write down cos 2x plus sine 2x, and then that's getting multiplied by dx. Basically, what I've done here is I've managed to write cos 2x sine 2x as du over negative 2. And my u substitution happens to be this. So basically what I've got here is I've got the green part is equal to du over negative 2. So that's going to be du over negative 2. And I'm just going to get 1 over u. And that's pretty much it, because we've got 1 over negative 2. So that's, I'll take that out of the bracket, out of the integral. And I'm going to get 1 divided by negative 2, which I can rewrite this as just negative half. So I've got negative half times 1 over u du. So this is just negative half ln of u plus c. Then I'm going to get negative half ln, get rid of the u, and put in cos 2x minus sine 2x plus c. And you're done. That's a ridiculously, like, it's one of those questions where you just go, I can't believe that was such an easy merit. But it just means that you just need to be aware of these kind of questions, right? If you ever get stuck, use substitution rule. It will work. Integral, but with missing negative sign. Well, look at the answer schedule, because this is pretty much what they've given right there. That's all they've given. They don't really kind of mention anything about how they got that part, or did they just substitute negative 2? Yeah, I'm not sure. I think they substituted negative 2 in the numerator, and then they've got the negative half outside. But that's, yeah, it's pretty kind of tricky to kind of get the answers from there. Hopefully the substitution one helped. All right, so let's go to the next question. What do we got for the next question? Fun times. All right, folks. So for this question, the first thing we want to be doing is coming up with a differential equation. Now, in the answer schedule, they actually wrote this as the differential equation. So they went dv dt equals, so that's the volume, the rate of change of the volume of liquid. That is this part right here. Change of volume of liquid. So that's the dv dt part, is proportional to the square of the volume. So square of the volume, that's going to be v squared. And we don't know what that proportion is, so that's going to be k. And it's remaining in the container. Now this is where I kind of was like, well, what happened? In the answer schedule, they had it as minus kv squared, because it's the amount of chocolate that's actually remaining. Now, one thing I did do was I did try this question with it being positive k, just to see what would happen. And, you know, and my assumption here is that if k is a, you know, if I write this as k as positive here, but with the information that I get, it should kind of work out in the end. And of course, I will show you what my prediction is at the end, but I'm going to follow this minus kv squared. And let's say you did it with just positive kv squared. I will show you what that looks like as well, but that's more of a rough worker anyway. So we've got this right now, dv dt is minus kv squared, and it basically says after 1 hour of use, so when t is equal to 1, our volume is equal to p, and then after a further 1 hour, so that's when t is equal to 2, our volume is 4/5 of p. So, and we need to figure out what the solver to calculate how much liquid was at the start of the day. So we're basically looking for when t equals to 0, what was the original volume there. So we've got a bit of a few steps that we need to do. So the first thing we're going to do is we are going to separate the variables. So we've got dv over v squared equals negative k dt. So now we're going to integrate both of this. So this will become, I need to bring this to the numerator first before integrating, negative k dt. So I'm going to integrate this. So this will become v negative 1 divided by the new power, which is negative 1, equals negative kt plus c. Now what I can say is I can rewrite this as negative 1 over v equals negative kt plus c. Now I've got two negatives there, and and I think this is probably why they did it this way, but it doesn't really matter. I'm going to get rid of that negative. By getting rid of that negative, I can rewrite this. Let's kind of think about it like this. I want to divide the whole thing by negative 1 and divide this by negative 1 as well. When I do that, I'm going to get negative 1, they cancel out each other, so I'm going to get 1 over v equals kt plus, now in the answer schedule they actually changed this to d because of the negative 1, but again I don't think it matters as much, but you can change it to d if you want. And again, I'll show you my other working just to show you how I came about with this. So we've got our first initial equation. Now it basically says when t equals to 0, v is equal to p. So we've got 1 over p, not t is not equal to 0, 1, sorry. We've got k times 1 plus d. So we've got 1 over p equals k plus d. We can't really do anything further here, so we're just going to kind of stop this here. And we're going to go into t is equal to 2 and see what we can do with that. So when t equals to 2, v is equal to 4 over 5p. So we've got 1 over 4 over 5p equals k times 2 plus d. And so what we've got here is 1 over, I'm just going to put that as 0.8p equals 2k plus d. Now, hopefully you can see that we've actually got a pair of simultaneous equations. So this is your first sum and this is your second, and so these are two simultaneous equations. We're going to stack them on top of each other to get rid of the d. So my first equation, I'm going to put it as 2k plus d equals 1 over 0.8p, and my second equation, I've got k plus d equals 1 over p. And what I'm going to do is I'm going to subtract each of those things. So 2k minus k is just k, d minus d is 0, and then here I've got 1 minus 0.8p minus 1 over p. Now just to make things a little bit easier, what I'm going to do is I'm just going to do 1 divided by, no, I'm going to get rid of all of this, all clear. I'm going to do 1 divided by 0.8. When I do 1 divided by 0.8, I'm going to get 1.25. So k is equal to 1.25p, 1.25 over p minus 1 over p. So k is equal to 0.25 over p, which gives me that k is equal to 1 over 4p. Now that I have k equals to 1 over 4p, I can figure out what the letter d stands for. Because in one of my equations, I've got 1 over p equals to k plus d. So remember that this equation is from here. So then I've got 1 over p equals 1 over 4p plus d. So then d is equal to 1 over p minus 1 over 4p. So d is equal to, I'm going to have 4 over 4p minus 1 over 4p. So d is equal to 3 over 4p. And basically, with all of that, I actually have my equation. So my equation is 1 over v equals kt plus d. But my v is what I'm trying to figure out. The k value was 1 over 4p times t plus d, which happens to be 3 over 4p. So I want to know when t is equal to 0, what is the volume? So 1 over v equals 1 over 4p times 0 plus 3 over 4p. I'm going to get 1 over v equals 3 over 4p. Cross multiplying, I get 4p equals to 3v, and v is equal to 4p over 3. So we can basically say initially container had 4p over 3 liters of chocolates to start with. A little bit of a nice question, because it's using simultaneous equations, and then it's kind of like making you, I think it's a great excellence question, to be honest. It's a really good excellence question, because it does make you think, and you kind of need questions like that. You can't just get like the previous one, in question 1e, that was a straightforward excellence question. So like this question, it makes you think. Grades wise, achieved is getting to this part right here. Merit is finding k in terms of p, so somewhere here, or you could get for 3 over 4p. Reaching stage 2 of the solution. Stage 2 of the solution is reaching it up to here, can get you an E7. I'm trying to see where it is. And then E8 is the final part there. Now, I did say to you folks that what happens if you actually had done it with k as positive? So if we did dv dt equals kv squared. This is not the best work. I did do it as positive k, just as a quick rough sketch. And when I did that, I actually got k as negative 1 over 4p, and I didn't even change the c value. I was just being purely lazy. And I ended up with negative 3 over 4p, and lo and behold, I got the final answer there, which was still 4p over 3. So yes, that is pretty much question 2 for us. We go to question 3 next. Now, if you know me, you know that I hate this question. I hate the Simpson's rules. I hate trapezium rule. God, sometimes excellence questions take far shorter than doing Simpson's rule. But here we go. Find the equation, which is right there, this ugly looking equation. I'm going to copy this down. All right, so let's do this. So we've got, I don't think we've got too many, so it's all right. So we've got y0, y1, y2, y3, and y4. Simpson's rule says that we're going to put this as, where do we put this as? 1/3, 1/3, b over a doesn't really give us. So I'm going to go back and copy the formula first. Which is approximately 1/3. No, 1/3. The h is b minus a over n. So we've got b minus a. So that's going to be like, we'll figure it out. 1/3 of h, and then y0 plus y4 is what we have, plus the odd ones, 4 times y1 plus y2, no, y3, that's the odd ones, plus 2 times y2, and then h is b minus a over n. All right, sorry, I just have to write this down. There we go. Now, what we've got here is b minus a, so that's whatever this value is, that's b and that's a. So h is equal to 12 divided by 4, so h is equal to 3. So we're going to get 1/3 times 3, so that's going to be 1. y0 is 10, plus 14 is y4, plus 4 times 13 plus 15, plus 2 times 16. So that's going to become 1/3 times 3 is just 1. We've got 10 plus 14 plus 4 times 28 plus 32. It's actually not too bad today. Putting that all together, we've got 24, 112, and 32. That's going to be 168 meters squared. How long did that take? 2 minutes 40. Okay, maybe I lied. Anyway, personal grievance between trapezium rules and Simpson's rule. I just ridiculously hate them. We'll go on to the next question. All right, so question 2. What we've got here is square root of x minus 3. So I'm going to separate that first as square root of x over square root of x minus 3 over square root of x dx. So we've got integral of 1 minus 3x to the power of negative half dx. And then now I'm going to integrate this. I'm going to get x minus 3x, negative half plus 1 is positive half, divided by positive half, and of course don't forget the plus c. So we've got x equals x minus 3 divided by half is 6. 6x to the power of half plus c gets us an achieved, and we go to the next question. All right, so with this question we are gonna have to go back to the formula sheet, and we're looking for, which one are we looking for? Products, is it? Yeah, I think so. Let's have a look again. So what we're looking for is integral between pi over 3 and 0, 5 sine 3x and sine of x. All right, so what we're going to do is go into formula sheet, and we're going to use, we've got sine and sine. So sine and sine is this one here. So we're going to use that one. But because we've got 5 in the front of it, and what we want is 2, so we're going to, actually, let me just copy that down here. So we've got 2 sine A sine B equals cos of A minus B minus cos of A plus B. So this is from the formula sheet. Now, because we've got a 5, what I'm going to do is I'm going to take 5 over 2 out. So if I take 5 over 2 out, limits still stay the same, then this will become 2. So it'll become 2 sine 3x sine x. Because now, because I've got 2 sine A sine B, it's very easy to substitute it with cos A minus B minus cos A plus B. So I'm going to rewrite this as 5 over 2 integral of pi over 3 0, and I've got cos 2x minus cos of 4x dx. Now I can integrate this. I've got 5 over 2. Integration of cos 2x is sine 2x over 2 minus sine 4x over 4. And that's all between pi over 3 and 0. So again, like I said before with question 1e, I am going to show the working here. So I've got 5 over 2 brackets. The first bracket is going to be sine 2 pi over 3 over 2 minus sine 4 times pi over 3 over 4, and then that's going to be minus by sine of 0 over 2 minus sine of 4 times 0 is 0 over 2. And here's where I'm going to stop. All right, because what I'm going to do is I'm just going to, like I said, these parts, it's so easy to make mistakes. I'm just going to go to integral, and I'm going to put in 5 sine of 3x, and I got sine x, and that's between 0 and pi over 3. Make sure I put that as that right there. Solve that. I'm going to get 15 root 3 over 16. And looking at, if I want to change it to decimals, I can put it as 1.62. Looking at the answers, there's our answers right there, 1.62 or 15 root 3 over 16. So, like I said, I mean, like, look, anytime it comes to integral questions like this, you know, show the working, but then just do the actual question in the calculator, because you're gonna save so much time. I mean, I would hate putting that in the calculator and then making a silly mistake somewhere. Okay, so that's question C. In terms of grades, correct integral is going to get you an achieved. So where are we looking at? Integral, we'll probably be looking at here for an achieved. And then a merit is correct area with evidence. With evidence, and I think with evidence of integration. So you can't just put this in the calculator and just get it. You have to show that integral part, the integration part, to get the achieved grade. All right, so going to the next question. So we got acceleration and t equals to 0. Object has a velocity of 5. Find the... Okay, so this is just a nice straightforward question here, because we've got t equals to 0, velocity is 5, and the question's asking when t is 4, what is the velocity? So we have to integrate acceleration to get to velocity. So acceleration equals e to the power of 2t divided by 4e 2t minus 3. So velocity is integration of this. Now, the thing about this one again is we can actually use substitution, but I think this is given to you in your formula sheet. I'm just trying to look at this. Hang on, let me just have a look. Yes, it is. F dash of x. Here we go. So in here, when you see this particular thing, when, oh, sorry, I'm trying to show this part here, actually. Yeah, just this part here. So when you have the differentiated function in the numerator, and then you've got the function in the denominator, then you can actually put that as ln of fx plus c. Now, when it comes to our question here, I can see e to the power of 2t at the top. I can also see e to the power of 2t in the denominator. So I know I can do this, but you know, we can always do substitution if you do get stuck with this. So I'm going to go u equals 4e 2t minus 3. Then du over dt would then equal 8e 2t. Oh, sorry, let me just do that again. 4e 2t stays the same, and I've got to multiply by the differentiation of that power, so it's going to become 2. So I can then say that du over, well, actually no, I'm going to do one extra step here. So this is going to become 8e 2t, and then du over 8e 2t equals dt. Because what I'm going to do is I'm going to substitute this. I'm going to put everything as it is so you can kind of see what's happening. I've got e to the power of 2t. Now the 4et minus 3, this is equal to u. So I'm going to put that as u. And then dt equals this entire thing here, which is du over 8e 2t. Now because the 8e2t, well, I can actually cancel that out. And when I cancel that out, I get 1 over 8u du. Integrating this, I'm going to get 1 over 8 ln of u plus c, which is the same as 1 over 8 ln of 4e2t minus 3 plus c. So correct equation for v with evidence of correct integration gets you an achieved. So this part right here gets you an achieved. Now we need to figure out what the c value is. So to figure out what the c value is, we've got t equals to 0, v is equal to 5. So remember, this is velocity function. So 5 equals 1 over 8 ln of 4e2 times 0 minus 3 plus c. So we got 5 equals 1 over 8 ln of e to the power of 0 is just e to the power of 0 is 0. 4 times 0 is, no, hang on, what am I doing? E to the power of 0 is 1, so it's 4 times 1 minus 3 plus c. So 5 is equal to 1 over 8 ln of 1 plus c. Ln of 1 is equal to 0, so we're going to get 0 plus c, and then c is equal to 5. So now we've got v is equal to 1 over 8 ln of 4e 2t minus 3 plus 5. We now know t is equal to 4, and we're trying to figure out what the v is. So we got 1 over 8 ln of 4e 2 times 4 minus 3 plus 5. Now we've got to actually use the calculator for this. I mean, I don't think there's a shortcut way of doing this or anything. So we've got 1 over 8 1 over 8 multiplied by ln of 4 shift e to the power of 8 minus 3 close bracket plus 5. That's going to give us v of 6.1732 meters per second. So this part here is worth a merit for this question, for getting the final velocity. So again, you know, like I said, if you do get stuck, always use substitution. Works wonders, substitution. All right, let's go to the last question. Oh, differential equation, a beast of a differential equation. I need to pause and have a look through this question. Actually, it's not too bad. I actually thought it was going to be a bit more crazy than this. It's just a bit of rearranging, folks, and then trust me, you'll be fine. So I'm going to write it like this: 1 minus x squared, 1 plus y, dy dx, and I'm going to take the 1 minus x and 1 minus y squared to the other side, which means it's going to become negative 1 minus x, 1 minus y squared. Once that's done, I can now bring all the x's to one side and bring all the y's to the other side. So I'm going to get 1 plus y divided by 1 minus y squared, dy equals negative 1 minus x over 1 minus x squared, and the dx is just going to come here. So all I've done is I've just moved those around. Now I can factorize the denominator here, because this will become 1 plus y and 1 minus y, and then here I'm going to get 1 minus x and 1 plus x dx. So at this point I can cancel these two, cancel this, and I'm left over with just 1 over 1 minus y dy equals negative 1 over 1 plus x dx. So I've got to integrate both of these things now. So when I integrate the first one, I'm going to get ln of 1 minus y, and that's going to get divided by the differentiation of whatever this is, which is negative 1, equals, I've got negative 1 ln of 1 plus x, and of course I need the plus c as well. So what I have here is negative ln of 1 minus y equals negative ln 1 plus x plus c. And if you look at it, we've got, given that y equals to 0 and when x equals to 2, we can figure out what the c value is. So it says when y is equal to 0, x equals to 2 when y equals to 0. So negative ln of 1 minus 0 equals negative ln of 1 plus 2 plus c. And so we've got negative ln of 0 minus negative ln of 3 plus c. This is ln of, sorry, that's not ln of 0, it's ln of 1. Now this is equal to 0. This is negative ln of 3 plus c. So c is equal to ln of 3. That's not too bad so far. And then we just got to find the values of y when x equals to 6. So I'll go back to my original equation, which is negative ln of 1 minus y equals negative ln of 1 plus x plus c, which happens to be ln of 3. Now it says x is equal to 6, and we want to figure out what y is. So negative ln of 1 minus y equals negative ln 1 plus 6 plus ln of 3. We have 1 plus 6. 1 plus 6 is that. Alright, that's looking good so far. What can we do? 1 plus 6. Let's get rid of this negative here, because I can divide this by negative 1 and divide all of these by negative 1. So I'm going to get ln of 1 minus y equals ln of 7 minus ln of 3. So that's going to be ln of 1 minus y equals ln of 7 over 3. Log rules. You know, when we do log a minus log b, you're going to get log a divided by b. And at this point, I can just say 1 minus y equals 7 over 3. And then negative y equals 7 over 3 minus 1. Negative y equals to 4 over 3. And then y is equal to negative 4 over 3. I'm surprised. This is such a weird question, because it's like, I thought it would be a lot more crazy than this. I didn't expect it to finish it that quickly. It's actually not too bad. I think that the hardest part is, well, it's not the hardest part. The tricky part is just the rearranging it. Once you rearrange it, it's fairly straightforward for an excellence question. Grades wise, number 1 is getting the plus C part. This is going to be your achieved. Merit is finding it with ln of 3. So getting up to here is going to be a merit. And excellence is obviously getting the negative 4/3. There we go. That's pretty much the question. Now, right screen. Let's go here. So as you can see, cut scores for this particular paper. Wow, a merit is a 13 for a merit. That is, yeah, I think that was 13 to 18 for a merit. That is that's an easy paper to get a merit, folks. Excellence is only worth a 19 as well. Man, this was a nice paper. I think maybe they might have just felt that the questions were challenging. I don't know. I look at that, question 1E. Maybe that's why. 19 is very, very generous to get a excellence for this particular paper. Anyway, that is what it is. All right, folks. So if you have any questions or comments, do drop it in the comment section below. Now, and if you've been one of those viewers that has actually kind of stayed through the last 3 years working on NCEA papers on this channel, thank you for your support. Do share my, details to other kids. They've got no idea that I exist. And also, some folks like to unsubscribe, which is fine, absolutely fine. But if you do stay subscribed, just make sure you switch off all the notifications, because I do tend to go content crazy every now and then. But apart from that, all the best for your exams and all the best for your future. And if you do see me outside in the real world, come and say hi. All right, see you guys. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.